Hello. Hello.
Hello, sir.
Is my voice audible?
Yes, sir.
Okay. So, what we were discussing in our last class?
So we completed words filling reaction, fitting reaction.
Urge fatigue reaction. Okay. So, what happens in urge fatigue reaction? What happens in urge fatigue reaction?
Sir, haloarene reacts with sodium and haloalkane to give alkyl benzene.
Okay. So, yesterday we have seen urge fatigue reaction. Now, we will be seeing another name reaction, that is urge reaction. This is another name reaction known as urge reaction. Only urged. Urge reaction. So what happens in urge reaction is that we take two molecules of alkyl halide or haloalkane, no haloarine has been taken, and we react with sodium metal. We take two molecules of alkyl halide, we react with sodium metal in presence of dry ether. So from here again the same thing, NaX will be removed. Okay, and you are going to get R bonded with R plus two molecules of NaX are removed. This is your alkane. So what happens in Urch reaction is that here we take two molecules of alkyl halide. Okay, therefore we get two alkyl connected by a single bond forming an alkane. So now if I take chemical example in this case, let's suppose I am taking an CH3Cl. Okay, this is CH3Cl plus 2 sodium metal plus again CH3Cl. So what I'm going to get product over here, and we are using sodium. So sodium should be used in dry medium because sodium cause explosion in moisture. Okay. So what will happen over here in this reaction, as you can see, this halogen means these two chlorine atoms will be removed along with sodium atom. So what you will get, this CH3 will be now bonded with this CH3, and therefore you will be getting CH3 single bond CH3. And CH3 single bond CH3, what is the formula? C2H6. And the C2H6 belongs to the name of ethane. So it leads to the formation of alkane called ethane. Understood Urge reaction?
Yes, sir.
Okay. So in what happens in Urge reaction is that, as you can see, the number of carbon atoms get doubled. In if I want, I can write in this way also. The same reaction. Let's say I'm taking another example. Let's say example number two. So in this case, I'm taking two molecule of C2H5Br, and I'm reacting this alkyl halide with two sodium metal in presence of dry ether. Okay, in presence of dry ether. So what you are going to get product over here? Can you draw out the product?
Yes, sir.
Please draw the product. The reaction is same. Instead of writing separately CH2Br two times, I have written 2 CH2Br at once. Done? What will be the product?
Sir, Sir, C2, no, like CH2 single bond CH2 plus NABR.
What CH2 CH2? From where CH2 has come? From where did you get CH2? Where is CH2 CH2?
Sir, C2H5.
Hmm. So
Sir, C2H5, C2H5 single bond C2H5 plus NABR.
C2H5 single bond C2H5. So instead of writing like this C2H5 C2H5 two times, instead of this I can write C4H10 directly.
Yes, sir.
So you can call in this way also. Plus two NABRs has been removed. So actually, if you will see what happened in reactant, you are having two carbon. In product, you are having four carbon. So it is also said like this that in Urge reaction, the number of carbon atom gets doubled. So if in examination any conversion type of question comes where you see that in reactant you are having two or four carbon and in the product you are having just double the number of carbon present in the reactant. So that means which type of reaction that will be? That will be your Urge reaction. So in any question, if you see that in product the number of carbon atom is double, then directly Urge reaction must strike to your mind. Okay.
Yes, sir.
Okay. Now after Urge reaction, I am having one more name reaction known as fatigue reaction. Another name reaction is fatigue reaction. FITTIG, fatigue reaction. Fatigue reaction. Like in Urge reaction, we reacted two molecules of alkyl halide or haloalkane with sodium metal. In fatigue reaction, we will react two molecules of haloarene, not haloalkane. We will react two molecules of haloarene with sodium metal. Okay, so I'm giving an general example. So let's suppose this is your haloarene, one haloarene, two moles of sodium metal, again one more haloarene. So again the same thing will happen. The halogen will be removed out of this reaction along with sodium metal. Therefore, as you can see, these two benzene ring will be connected with one another. This is one benzene ring and it will be connected with the another benzene ring. Okay, so this now becomes biphenyl. The name of it, this compound is biphenyl because as you can see there are two phenyl group. The formula of this is C6H5 and the formula of this is C6H5. And you know the C6H5 means not benzene. C6H5 means phenyl. So here two phenyls are combined through a single bond over here. So therefore it is known as biphenyl or you can call it as diphenyl also. So always in fatigue reaction, you are going to get biphenyl as your major product. None other product you are going to get over here. Now let's suppose if I am taking a chemical example, okay? Let's suppose I am taking chlorobenzene and I am reacting with 2 moles of sodium and one more chlorobenzene means 2 moles of chlorobenzene has been reacted with 2 moles of sodium. So what will happen? These two chlorine will get removed out of the reaction along with two sodium metal. Okay, and make sure the reaction takes place in dry ether again. Dry ether must not be missed. Why? Because sodium metal is used and sodium metal is highly explosive in contact with moisture. So what will happen over here? Here also two molecules of sodium chloride NaCl will removed out of the reaction and both this ring will bonded with each other through single covalent bond, therefore forming a compound called as biphenyl or we call it as diphenyl. Understood this reaction?
Yes, sir.
Hmm. Write it down. Done.
1 second, sir. Done, sir.
Okay, next reaction. Reaction of magnesium metal with haloarine. So this is my haloarine. Okay, let's say I'm taking one haloarine, let's suppose bromobenzene, and I'm reacting this haloarine with magnesium metal. Again, we will be using dry ether as a solvent. So what will happen? As you have seen, if you remember in our last class, when we used to react haloalkane with magnesium metal, so we get Grignard reagent. Okay, that I think you must remember from the last class. That last class also we have done similar type of reaction, but there in the last reaction we reacted magnesium metal with haloalkane. Here we are reacting magnesium metal with haloarine. The difference is between haloarine and haloalkane, but you will be going to get Grignard reagent in both the cases. There you got RMGX, but here you will get ARMGX. AR means aromatic ring, magnesium, and then bromine. This way. This is the product which you are going to get. This is the aromatic ring called benzene ring, then magnesium bonded to it, and then bromine. So this will be your Grignard reagent. Again, this is also called Grignard reagent. Understood?
Yes, sir.
So this reaction is again an important reaction for your examination. Now, next reaction is your Ullmann reaction. Ullmann reaction. Ullmann reaction. What happens in Ullmann reaction is that instead, we particularly means the scientist Ullmann particularly took iodobenzene. So whenever if question comes in exam to write about Ullmann reaction, we it is necessary to take iodobenzene also from our side, because in name reaction you cannot make changes by yourself. Okay, if the scientist has this particular reagent, particular reactant, then you have to use the same reactant and reagent. Okay, so this is Ullmann reaction. So he used iodobenzene, so he used 2 moles of iodobenzene, and along with that he used copper powder, 2 copper powder and 2 moles of iodobenzene. So again, like NaX was removed, here also 2CuI2 will be removed. 2CuI will be removed out of the reaction. Okay, minus 2CuI, copper iodide will be removed, and again this benzene ring will be connected to the another ring forming biphenyl, or we call it as diphenyl. Very simple reaction. Means this reaction resembles to the Fittig reaction, but the difference between Fittig and Ullmann is that Fittig took sodium metal for formation of biphenyl, whereas Ullmann took copper powder instead of sodium metal. Okay, this is the basic difference between them. Done?
Yes, sir.
Okay. Now, one question is asked in examination from polyhalogen compound, and the question is in this way: why chloroform? Why chloroform is stored in dark colored bottles? Why chloroform is stored in dark colored bottles? Why chloroform is stored in dark color bottle? Or this question can be also asked in this way: why chloroform is kept away from direct sunlight? Kept away from direct sunlight. Why chloroform is stored in dark colored bottles? And the similar question, but the language is different. It can also be asked in this manner. Why chloroform is kept away from direct sunlight? Okay.
Yes, sir.
Okay, first I will explain the reason, then I will make you write. The reason for this is that because if chloroform comes in contact with oxygen, or it comes in contact with the sunlight, so what happens is that chloroform gets oxidized. Okay, and chloroform, after getting oxidized, it leads to the formation of toxic gas known as phosgene. Therefore, chloroform is stored in dark color bottle. There is only one reason that chloroform is kept away from sunlight or is stored in dark color bottle, is that because as soon as it comes in contact with the oxygen of the air, it gets oxidized, and oxidation of the chloroform leads to the formation of a poisonous gas, a very poisonous gas, toxic gas known as phosgene. Therefore, it is not stored in the dark colored bottle. So now you may write down the reason. Because, write it down, because CHCl3, the formula of chloroform is CHCl3 trichloromethane, is slowly oxidized by air, is slowly oxidized by air, oxidized by air, is slowly oxidized by air in presence of light, in presence of light, in presence of light, in presence of light, to an extremely poisonous gas, to an extremely poisonous gas, to an extremely poisonous gas called as phosgene, called as phosgene. Mark this word, phosgene. This is the poisonous gas, phosgene. And the reaction is in this way: 2CHCl3 chloroform oxidized, means it comes in contact with oxygen to form COCl2, COCl2 plus 2HCl, plus 2HCl. This is your phosgene gas. This carbonyl chloride is known as phosgene gas. So this is a question from polyhalogen compound which is repeated many times. So I made you write. Just remember this. Good, because I think it was this question was asked in 2023 or 2022. In between, most probably I think it was asked in 2023, 99%, but 1% chance, well, it might be asked in 2022. But in between these 2 years only, this question has been asked. Okay, so this question has been asked by the board examination very frequently. Okay, so very simple question, 1 mark question, direct answer. Because due to oxidation, it leads to the formation of poisonous gas, phosgene. If you want, you can write down the reaction. If you do not want, or if you have any confusion in writing the reaction, please do not write the incorrect reaction. Only write down the statement. Otherwise, if you will write the incorrect statement, incorrect reaction, then the correct statement will also go wrong, because when student write reaction, teacher do not look, or the examiner do not look at the statement or the theory written by the student. They directly look at the reaction, and if your reaction will be wrong, you are not going to get awarded even a single marks, even if you have written the correct theory. Understood?
Yes, sir.
Okay, so done with this.
Yes, sir.
Okay, now we will be starting with our new chapter. So this chapter has been completed. Okay, we have discussed all these important topics related to examinations and all. Okay, now it's your part to solve the questions. Okay, take the previous year question, previous question, and do solve the questions from haloalkane and haloarene. And if you found any type of problem in any part, or you are unable to find out the answer, you feel very free to approach me. Okay.
Okay, sir.
Okay, so next chapter that we are going to do in organic chemistry that you also know is alcohol, phenol, and ether. Alcohol, phenol, and ether. Three functional groups are these. These are three functional groups. Chapter number 2, that is alcohol, phenol, and ether. Phenol and ether. Look, we will be studying alcohol and phenol together, and after completing alcohol and phenol, then at last we will be studying ether. Okay, because ether is a very small topic and there is no relation of ether with alcohol and phenol. So first we will be discussing all the method of preparation, physical, chemical properties of alcohol and phenol both together because they have a relation between them. And then after completing this, we will be doing with ether. Okay, so now let's understand what is this alcohol. You know that alcohol is a functional group. How to identify that my organic compound contains alcohol functional group or not? So it is very prominent that if you see OH group, which group? OH group. If OH group is attached to the carbon organic compound, so that means that organic compound is containing alcohol. Okay. So whenever you will see OH group attached to aliphatic chain, that means that belongs to alcohol functional group. Now, suppose you are having RH. This RH is nothing but alkane. Okay, and from here, if I remove one hydrogen and instead of one hydrogen, if I substitute one OH, so then you are going to get ROH. So this becomes your alcohol, which I was talking right now. Okay. Now let's take a chemical example. Suppose I am taking a methane. So what is the formula of methane? CH4. Okay. Now if I am substituting one hydrogen with one OH group, so what you are going to get? CH3OH, isn't it? This will be the product after substituting hydrogen with OH.
Yes, sir.
So this is known as methanol. It is known as methanol. Why methane? Because one carbon is there. And why we are using ol? That you must have studied in class 10th also. This ol is the suffix which is used in case of alcohol as a functional group. So whenever alcohol is present in the organic compound, it is represented by the suffix ol that is added at the last. Similarly, you are having, let's take another example. This is ethane. This is another alkane. Now remove one hydrogen and instead of that add one OH. So then what you will get? When you will remove one hydrogen, it will become C2H5, and when you have added OH, it will become C2H5OH. Now what is the name of this compound formed? What is the name of C2H5OH?
Sir, ethyl, ethyl alcohol.
Ethyl alcohol, yes, correct. But ethyl alcohol is the common name. What will be its
Ethanol, sir.
IUPAC? Yes, ethanol, exactly. Because two carbon are there and both the carbon are connected with single bond. So it becomes ethane and OH group is there. So suffix ol will be added. Therefore, the IUPAC name becomes ethanol. And if you look in ethane, I am not writing E at the last. In ethane, I have written only till N, and after N, I have written ol. So you have not to write E like this. This is not the correct order of writing. Why? Because this E and this O, both of them are vowel. Both of them are vowel. And two vowels in organic chemistry cannot come together. So if two vowels are coming together, so in that case, the IUPAC rules tells that you have to drop the previous vowel, the vowel which come first. Therefore, we will drop E and we will write ol. Okay.
Yes, sir.
Now, I think you have understood what is alcohol, how to identify alcohol, how to write its IUPAC name. Now let's talk about this phenol. What is this phenol? Look, suppose you are having a benzene ring, okay? Suppose you are having an aromatic compound. Let's say you are having benzene ring over here. And you know that in benzene ring you are having 6 carbon bonded with 6 hydrogen also. Okay, so now if you substitute any one of the hydrogen by OH group, here also we have to substitute hydrogen by OH. So what will happen? You are going to get a structure like this. Suppose I am substituting hydrogen from this point. So here OH will group will come, and this is your phenol. So this is your phenol. Understood? Means in phenol you do not have much thing. In phenol, whenever a phenol word comes, that means this structure is only there for phenol, no other structure. Phenol means OH attached to benzene ring. That's it. Okay.
Yes, sir.
Okay. So alcohol means OH group will be attached to, like as you can see in the above example, OH group is not attached to the aromatic ring. OH group is attached to the aliphatic chain, means the carbon atoms present in a straight chain or the branch chain. But when the OH group will be attached to the aromatic ring, as in the case of phenol, so that will be phenol, not alcohol. Both at in both the places you can see the OH group, but in the above example, the OH group is attached to the carbon atom of aliphatic ring, whereas in phenol, OH group is attached to the aromatic ring. Okay, so when OH group will be attached to aromatic ring, you cannot call it as alcohol. Got it?
Yes, sir.
Now, one question comes on the basis of a structure of alcohol. So write down on a question. The question comes in this way: give reason, give reason, give reason in alcohol bond angle of is 108 degree 9 minutes and not 109 degree 28 minutes. This is the question asked from structure alcohol. So the question says that in alcohol, if we take any alcohol, so the bond angle in alcohol should be 109 degree 28 minutes. But when it is experimentally calculated, the bond angle is found to be 108 degree 9 minutes. That means the bond angle decreases approximately by 1 degree. And why so? Look, why I am saying that in alcohol the bond angle should be 109 degree and 28 minutes. If you look at the structure, carbon oxygen, I am talking about this bond angle. As you can see, this bond angle, carbon, oxygen, and hydrogen. I am talking about this bond angle. So this bond angle in alcohol should be 109 degree 28 minutes, but it is less than that. Why it should be 109 degree 28 minutes? Because if you will look at the hybridization of oxygen, what is the hybridization of oxygen, Darshan? How to calculate hybridization? I gave you the formula in the very first class of haloalkane haloarene.
Sir, number of sigma bonds minus number of pi bonds.
Not minus, plus number of lone pair, not pi bond.
Yes, sir.
Hybridization means number of sigma bond plus number of lone pair. So how many sigma bonds are found by oxygen?
2, sir.
And how many, is there any lone pair on oxygen?
Yes, sir. 2.
2 lone pairs. So in total, 4. So if the value comes out to be 4, what is the type of hybridization?
Sir, SP hybridization.
How SP? In SP then it is 2. one S and one P.
Sir, sp3 hybridization.
Yes, sp3 hybridization. And if your hybridization is sp3, then what is the geometry? Tetrahedral geometry.
Yes, sir.
And in tetrahedral geometry, what is the bond angle? So in tetrahedral geometry, the bond angle is 109 degree 28 minutes. That is why it was expected that the bond angle should be 109 degree 28 minutes, because the hybridization is sp3, because the geometry is tetrahedral, so the angle should be that, but angle is less than that. The reason for that is because, as you can see, these two lone pair electrons on oxygen. So what does these two lone pair electron do? No, these two lone pair electron repel each other. These lone pair of electron repel each other, repel each other. So what will happen? This lone pair electron will repel the other one, and the other one will repel the first one. So what will happen when they both will repel each other? The bond, this OH bond and this CO bond will go towards downward, and therefore the angle will decrease. Understood how the angle decreases?
Sir, can you explain the decreasing part again?
Pardon? What did you say?
Can you explain the last one again? Like, how does the angle decrease?
Look, suppose these two lone pair are repelling. So if these two lone pair will repel, so this lone pair will come on this side, this lone pair will come on this side. So because these two lone pair are repelling, so what will happen to the single bond? There are two sigma bond, so the two sigma bond will also bend downwards. So like this. So now as you can see, earlier the bond angle were greater, but due to repulsion, now you can see the bond angle has been decreased. This is what I am talking about. This is how the bond angle decreases.
Yes, sir.
Understood?
Yes, sir.
So after drawing this diagram, I am making you to write a statement. So after drawing this diagram, you write down this statement. Okay. So due to repulsion between lone pair electrons on oxygen atom, due to repulsion between lone pair electron of oxygen atom, the bond angle, the bond angle, the bond angle in alcohol is lesser than tetrahedral angle, is lesser than tetrahedral angle. Okay. So this is the answer for the question. Done?
1 second. Done, sir.
Okay. Now write down one more question. Now again the question from structure part. The CO bond length, the CO bond length, the CO bond length in phenol, the CO bond length in phenol is less than is less than that in methanol, that is CH3OH. This is methanol. Give reasons. Written down the question.
Yes, sir.
So what does the question say? That in phenol also there is a bond length between carbon and oxygen, means there is a bond between carbon and oxygen. And in alcohol, particularly in this question, it is talking about methanol. There is the bond angle between, sorry, bond length between carbon and oxygen. As you will see in phenol. So this is your phenol, and here this is phenol. So as you can see, here is a bond between carbon and oxygen, this bond. Okay, question is talking about this bond. You know that here is the carbon present over here. Okay, so here carbon is bonded to oxygen. And in methanol also, this is the structure of methanol. Okay, this is your methanol, CH3OH. So here also you are having, as you can see, here also you are having one carbon bond, carbon oxygen bond, this one. Can you see this? So in phenol also you are
Yes, sir.
having carbon oxygen bond, and in alcohol also you are having carbon oxygen bond. Now the question is asking that the bond length, both the bond are single bond, okay? But the question asks that the bond length in phenol is less than that in alcohol. Means the bond length in alcohol, means carbon oxygen bond length in alcohol is more than the carbon oxygen bond length in phenol, even though both are single bond. How come this? What is the reason behind this? Okay, so if I talk about the reason, what is the reason behind this is that the reason is based on hybridization. If you look at the hybridization of both the carbons, first look at the hybridization of phenol, then I will tell about alcohol. What is the hybridization of the carbon in phenol? What is the hybridization of carbon in phenol?
Sir, sp3 hybridization,
No, sir. It is sp2.
sp2 hybridization, sir.
It is sp2. And the carbon of alcohol?
Sir, sp3.
Yes, sp3. Okay. So there lies a difference in the hybridization of the carbon in phenol and alcohol. Okay. So in phenol, the carbon to which oxygen is connected is sp2 hybridized, whereas in alcohol, the oxygen is attached to sp3 hybridized carbon. So, son, what does this role? What is the role of hybridization in bond length? So now you know that S character is directly proportional to electronegativity. That this you are knowing, right? Now, in sp2, what is the S character over here? Percentage S character. What is the percentage S character in sp2? That is 33.33%. And what is the percentage S character in sp3? That is 25%. So between sp2 and sp3, which hybridization is having greater S character?
Sir, sp2.
Yeah, sp2. And sp2 is having greater S characters. So the carbon which is sp2 hybridized will have more electronegativity than the carbon that is sp3 hybridized. Do you agree with this statement?
Yes, sir.
Okay. Now what will happen, because the carbon of the phenol is more electronegative than the carbon of alcohol, so what will happen, the carbon of phenol will pull the bond electron more towards itself as compared to the pulling of electron by the carbon of alcohol, isn't it?
Yes, sir.
In phenol, the carbon is more electronegative, so it will pull the electron more as compared to the carbon of alcohol, because the carbon in alcohol is having less electronegativity, so it will also pull the electron, but it will not pull the electron to that extent to which the carbon in phenol will pull the electron. So what will happen, because this carbon in phenol will pull the electron, so the bond length between oxygen and carbon gets shrink. That means the bond length decreases. Whereas in alcohol, the carbon does not has that much capacity to pull the electron. Therefore, the bond length is little bigger as compared to phenol. Understood?
Sir, can you repeat again?
Okay. So I was telling that in phenol, because the carbon is more electronegative, so it will pull the electron. No, you are knowing that, no, in phenol also we are having CO bond, and in alcohol also you are having CO bond. But what will happen in phenol is that the carbon in phenol will pull the bonded electron more towards itself, whereas the carbon in alcohol will also pull the electron, but will not pull the electron to that extent by which the carbon of phenol will pull the electron. That means if I term in a simple way, so the output of this is the carbon of the phenol will pull the electron more towards itself, therefore the bond length will decrease between carbon and oxygen. Whereas in alcohol, the carbon do not pull the electron towards itself, therefore the bond length remain bigger. Okay.
Okay, sir.
Now write down, draw these two figures and write down all those things I've written on the screen related to the figure, and then I am making you write the theory part.
Done, sir.
So write down the theory part. In phenol, in phenol, I'm dictating. Please write it down because currently my device is showing one note is not responding. So I'm dictating. Please write it down. In phenol, OH, in phenol, OH is attached to, yeah, it came. In phenol, OH is attached to, in phenol, OH is attached to more electronegative, more electronegative carbon atom. In bracket you can write the hybridization, sp2 hybridized. Therefore the bond length decreases. So this is the statement. Done?
Yes, sir.
Okay. So now we will be looking for the preparation of alcohol, how to prepare alcohol. Okay. Like we have seen preparation of haloalkane and haloarene. Similarly, there is preparation for alcohol, and questions from this part are very much important for your examination. Preparation of alcohol. First method of preparation of alcohol is, okay, so acid catalyzed acid catalyzed hydration, by acid catalyzed hydration. By acid catalyzed hydration. The first reaction is known as acid catalyzed hydration. Acid catalyzed hydration. Now, as you can understand by the name itself, what do we mean by hydration? Hydration means addition of water. Okay. Acid catalyzed hydration, that means addition of water in presence of acid as a catalyst. Means what we are going to do in this reaction is that we are going to take an alkene. Okay, to that alkene we will add water molecule, but the addition of water molecule to alkene will take place in presence of a catalyst, and that catalyst will be your acid. So therefore this reaction is called acid catalyzed hydration. Okay, so let's take an alkene. So I'm taking an ethene, CH2 double bond CH2. So this is your ethene. Okay, this is a symmetrical alkene. Ethene. This is your symmetrical alkene. Symmetrical alkene. You know that what is no symmetrical alkene? Symmetrical alkene means across double bond there are same number of carbon. So in ethene you are having one carbon on both sides of the double bond. Okay, so this is an alkene. To alkene, we will be adding water molecule, and the water molecule addition to alkene will take place in presence of a catalyst. Okay, so in this reaction, we will be using acid catalyst. So you know, instead of acid, if I will write H plus, then also it represents the acid, because acids are proton donor. This you know na. Instead of, suppose if I took H2SO4, so instead of H2SO4 I can write H plus also. Instead of HCl also I can write H plus also, because all the acid dissociate H plus ion in their aqueous solution. Okay, so whenever if I write H plus, then the question should not come in your mind that you sir told that we will take acid but you are writing H plus. Is acid. Okay.
Yes, sir.
Now, in H2O molecule, you know that there are two parts. One is your positive part, that is H plus, and another one is the negative part, that is OH minus. Now, just go back to the second or third class, and there also we have seen addition of alkene to HX. Do you remember Markovnikov's and anti-Markovnikov's rule?
Yes, sir.
Okay. So before coming on to Markovnikov and anti-Markovnikov, you know that the Markovnikov rule and anti-Markovnikov rule are used in case of unsymmetrical alkene, not in case of symmetrical alkene. So will we be using that rule over here in case of symmetrical alkene? So the answer is no. Okay. It is a symmetrical alkene. Now, what will happen in symmetrical alkene? So in symmetrical alkene there is no such compulsion that positive part will go on this carbon, negative part will go on this carbon. There is no such compulsion. You can bond the positive and negative part of water molecule to any of the two carbons. There is no such compulsion in case of symmetrical. So suppose if I'm bonding my hydrogen to this carbon, so it became CH3. Now double bond will change to single bond. And if I'm bonding one OH group over here, it will change to OH over here and it becomes H2. So what is this? This is called two carbon with one OH group. If I have to write this, I can write in this manner: CH3 single bond CH2OH. Okay. And what is this called, Darshat? What is the IUPAC name of this compound form as a product?
Sir, ethanol.
Yes, this is ethanol, right? It is ethanol. Yes. So from ethene we made ethanol, or the common name we can write ethyl alcohol. Okay. So this is a simple reaction. So in symmetrical alkene, no need to worry. You can add positive and negative part as per your wish. But what happens in case of unsymmetrical alkene? So let's take an example of an unsymmetrical alkene. So I am taking propene as an unsymmetrical alkene. So this is propene. Okay, this is an unsymmetrical alkene. And I am adding water in presence of acid. So can you draw out the product in this case, Darshan? What will be the product?
Sir, the bond will break, right?
Mm-hmm.
Sir, so CH3, um, CH3,
Is it
um,
symmetrical alkene or unsymmetrical alkene?
it is unsymmetrical, sir.
So in unsymmetrical alkene, addition will take place according to which rule?
Markovnikov rule, sir.
Markovnikov. Now what does Markovnikov rule says?
Sir, first thing, the bond will break, and after that, the halogen will be attached to the carbon atom.
Halogen is negative part, isn't it?
Yes, sir.
So halogen will attach to where? Which carbon?
Sir, halogen will attach to CH.
Yes, means halogen will attach to the carbon containing lesser number of hydrogen.
Yes, sir.
But here you are not having halogen. So here what is the negative part in H2O?
Sir, O.
Huh? What is the negative part? Which group is the negative part? You are having two group, H plus and OH minus. Which is the negative part?
OH minus.
OH minus. So OH minus will attach at the CH, okay, and you will be getting CH3 CH. On this you will be having OH. Now double bond will change to single bond, and the positive part will attach to that carbon containing more number of hydrogen. So the H plus will go to CH2 and will become CH3. So therefore the name of this compound is propane, because three carbon are there, and at position number 2 you are having alcohol. So propane 2-ol. This is the structure. Understood?
Yes, sir.
Okay. Now, for this reaction, you have to see mechanism also. Okay. So, mechanism. Now, we are going to see mechanism for this reaction. Mechanism. Mechanism for the first reaction. Which reaction? This reaction. CH2, double bond CH2 plus H2O in presence of acid will give CH3 single bond CH2OH. We are going to see the mechanism of this reaction. So a mechanism is how the reaction occurs, how we get product out of the given reactants. Okay, what is the phenomenon involved? Like in this, in the reaction which I have written on the screen, directly I have drawn the product. But here you have to understand how the bonds are broken down, what all things happen in reactant that it leads to the formation of that product. So there is a this is a three-step reaction. Okay, so it is a three-step reaction. So the first step is that this H2O will react with this proton H plus, which has come from acid. You know that this H plus has come from acid. So the water, first you look at the screen, then you will note it down. Okay, because mechanism first you have to understand. Okay, so now what will happen? You are having water. So the very first thing is alkene at first do not participate in the reaction. Firstly, water will react with the proton by the acid. How? This oxygen will donate its lone pair of electron and will bond with this hydrogen, because this hydrogen is having plus charge, means it is having deficiency of electron. So what will happen? This will form H3O plus will be formed. Now oxygen will be bonded to the third hydrogen. Now only one lone pair will be left to this oxygen, and because this oxygen has lost one lone pair of electron in bonding, so this oxygen will bear one positive charge. Okay, so it forms H3O plus. So what is this? It is your H3O plus. Understood till here?
Yes, sir.
Now, after the formation of H3O plus, then the role of alkene will come in play. This way. So CH2 double bond CH2. So this is your alkene, okay, plus H3O plus. So this is your H3O plus. Okay, oxygen is only left with one lone pair. Earlier it was having two, now it is having one positive charge also because it has lost electron. Now, what will happen? Oxygen is more electronegative than hydrogen, isn't it?
Yes, sir.
And oxygen is more electronegative. That means it has the, what we call, it is very hungry for the electron, for the need of electron. It is always in need of electron. So the positive charge on oxygen will be very unstable. It will make the compound unstable because oxygen is an electronegative element. And you know what is electronegative element? Electronegative element are hungry for the electrons. So here oxygen is very hungry for the electron. And what did we do? We took out the two lone pair electron from oxygen. Therefore, oxygen got angry and therefore it will make my compound unstable. So now what will happen? The oxygen will try to remove the positive charge as soon as possible. So how oxygen is going to remove this positive charge? So now the role of alkene comes. If you see in alkene, you are having a double bond over here, and double bond means you are having excess of electron. So what will happen? One pi bond will break and it will give electron to this oxygen. Pi bond will break and it will give electron to the oxygen. Now what will happen? Look, okay. So something this like this, you are going to get some phenomenon. But look over here. Now, as soon as oxygen will be bonded to carbon, oxygen will take one electron from hydrogen because it is more electronegative. So this hydrogen will become now H plus, and this oxygen will be bonded to any one of these carbons. So hydrogen will also be bonded to this carbon, and let's say oxygen is also bonded to this carbon, OH2. Now, if you see in the product, again oxygen is forming three bond. So again it will have plus charge because oxygen, you should keep this in mind. Wherever you see oxygen forming three bond, it will be a positive. That means again their positive charge has came on oxygen. Now, step number 2. What happens in step number 2? Now the H2O molecule becomes like nucleophile. So nucleophile attack of H2O on carbocation. Now, sir, I cannot see carbocation. Where is the carbocation? First, the carbocation will be formed, then only nucleophile will attack. I will say yes. How the carbocation is formed? Like as you can see in the above example, the last product, again the oxygen got the positive charge. Again, oxygen became unstable. Now, what will oxygen do? oxygen will take the bonded electron from this carbon and will say, carbon, you gave me the electron, because oxygen is more electronegative than carbon, and therefore oxygen will remove out of the reaction by forming H2O. And when oxygen will take the electron of this bond along with carbon, this carbon will bear positive charge. So forming carbocation. So this is your CH3 single bond CH, and now this carbon has positive charge. And this is carbocation. Now the H2 molecule which were removed in the above product will behave like nucleophile again. Will behave like nucleophile again and will again donate the electron to the carbocation. So what will it form? So it will form CH3 like this, CH3 single bond CH, and again to this CH your this will be connected again H2O. Sir, again I got the same product. Again I got the same product. Okay, again I got the same product, sir. Again oxygen got positive charge. Now what will happen in third step? In step number 3, CH3 CHOH2. Now again this oxygen will take one electron from this bond and this carbon will form carbocation. Okay, or no, wait, why to take this bond now? There is no need to take this bond now. Okay, so this H of the hydrogen, now the oxygen will take electron from this hydrogen, because as we have seen in the step number 1, the oxygen removed out of the reaction by forming H2O, and again it attacked for being nucleophile, and again we came back to the same state that oxygen is attached to the carbon bearing your positive charge. So now what will oxygen do is that now oxygen will take this electron, the electron from hydrogen. Now it will not take the electron from carbon, it will take electron from hydrogen, and this hydrogen will removed out of the reaction by forming H plus, and therefore you will be getting CH3 single bond CH2 CH2, okay, CH2OH. So this is the product, and here you have got the alcohol. So this is the 3-step mechanism. You can write it down. Are you able to see the screen?
So now I'm not able to see the screen.
What is the problem with this? Okay, I think there is some problem with this one note. I need to update it. Okay, let me fix the problem once. Okay, so you can draw this in next class. Okay, and I will explain you again this mechanism in the next class. Okay,
Okay, sir.
okay, thank you.